Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of area of a region created by functions, and we're going to try to approximate that area using rectangles. So given some region created by some functions, you can approximate that area because we know that the area of a rectangle is length times width. So I've given you some functions here just as a quick example so you can figure out what we're doing. Here's the function y equals x plus 1. It is right here. And then we have the line x equals 2 and the other vertical line x equals 0. And then on the bottom boundary we have the line y equals 0. So you can see that there's two discrete rectangles right there that are created that have the same width. Okay, the width of all the rectangles will be the same, and it'll be referred to as delta x. And it'll always have this formula right here. So it'll be b minus a over n, where n is the number of rectangles. If we're doing infinite number of rectangles, it'll stay n. If we're doing a finite number of rectangles, it'll be whatever that number of rectangles is. So I will be the rectangle number. Are we talking about the first rectangle? Are we talking about the second rectangle? That's what I is. So x sub I will be the endpoint, and it'll depend on whether we're dealing with the lower endpoint, the midpoint, or the upper endpoints. Usually we only deal with lower and upper. Might also be referred to as left endpoint and right endpoint. So the formula is as follows. The left endpoint is x sub I is a, which is the smaller of the two endpoints in the region, right? So a in this case would be 0, x equals 0, plus I minus 1, and we'll talk about I in a second, times that delta x here. Whereas if it's the right endpoint, it's going to be that left smallest bound of our region of interest, plus I times delta x. What does this I keep talking about? Well, when we're doing the summation version of this, the things you're going to have to memorize are as follows. The summation from 1 to n is going to be, of a constant, is going to be that constant times n. If it's I, it's going to be n times n plus 1 over 2, where if n is a finite number of rectangles, you just plug in whatever it is. And then if it's infinite, you're going to take the limit as n approaches infinity after you simplify. And I'm about to go through all that in here in a second. Here we have I squared and I cubed. So please go ahead and memorize those. Okay. So method 1 is more for applied calculus. They don't go through the i's like we do. You just set up the following table. You take f of xi times delta x, add them up. Okay. For differential calculus, the science-based calculus, is what you're going to have to do is just like the other method. First find delta x, then find your f of x sub I using the applicable lower or upper formula shown here in yellow down here. So is it lower? Is it I minus 1, or is it upper I? Then you plug into that formula right there, where your x sub I, the endpoint that you found, is going to have the n's no longer be numbers, and you're going to plug that into your function, whatever your f of x is. And then you're going to evaluate using the definitions that I told you to just memorize. And then you're going to plug in n, the number of rectangles. All right? All this will make more sense whenever you actually see it in action. But find delta x and then plug in into your function what x sub I is. I guess you should find technically delta x, and so if you find f of x I, plug it in, evaluate. The only difference if you have a number that's not finite, it's an infinite number of rectangles, step 4 changes to taking the limit as n approaches infinity. But either way, you get the correct answer. So I hope I've eliminated any doubts that you might have. Practice, practice, practice. You can see that this is only an approximation because there will always be an error associated with this rectangle method. The larger your number of rectangles get, the smaller this error will be, but still there is that error, whether it's overlapping or underneath, not enough or too much. All right, so integration is the way we will be handling it for the most part, finding area. But for now, to understand that concept, we're going through this process. All right, so check out the example videos, practice, practice, practice. Thank you and have a nice day.